In the previous video in this series, we saw how to access and query data using Spatial SQL in Wherobots Cloud via the Wherobots Open Data Catalog. In this video, we're going to take a look at loading and working with our own data in Wherobots Cloud, as well as creating and saving data as a result of our analysis, such as at the end of a data pipeline. So let's get started. I'm signed into Wherobots Cloud, and I've created my notebook runtime. If you'd like to follow along, you can create a free Wherobots account at wherobots.services. So in this video, we're going to take a look at loading our own files, importing data, including CSV, GeoJSON, shapefiles, GeoTIFFs, writing data as GeoParquet. First, let's explore loading a CSV file from a public S3 bucket. In our Sedona context, we'll configure the anonymous S3 authentication credential provider for the bucket to ensure that we can access this specific S3 bucket's contents. Note the name of the S3 bucket here. Most access configuration will happen here in the Sedona context configuration object in our notebook. We can apply these settings when creating the notebook runtime in the UI as well. We can also, if we're working with a private notebook, specify access keys, or for a more secure option, using AWS IAM role trust policy. Now we can use the S3 URL to access objects within the bucket. In this case, we'll load a CSV file, create our geometries, and now let's visualize this data set using Sedona Kepler. This is a data set of bird observations by species. And we can see that distribution of bird observations. Next, let's see how we can upload our own data in Wherobots Cloud using the Wherobots Cloud File Manager UI. I'm going to switch to the Files tab and the Data folder. Wherobots Cloud accounts include secure file storage in private S3 buckets specific to our user or shared with others in our organization if we use the shared directory. So we'll go into my user-specific directory. You can see other data that I have uploaded. I'm going to upload a GeoJSON file into this folder in Wherobots Cloud using the UI. This GeoJSON file has data on watershed boundaries within the US. Once the file is uploaded, we can click on this icon to copy the S3 URL for this file to access it in the notebook environment. So back in our notebook, I'll paste in the URL for this GeoJSON file. Now, this is a multi-line GeoJSON file where the features are contained in one large single object. We can also handle GeoJSON format where each feature is on a single line. So we'll use the built-in Sedona GeoJSON reader. The Sedona GeoJSON loader will parse GeoJSON exactly as it's stored as a single object. So we'll want to explode the features column, which will give us rows in our data frame containing each feature's geometry, and a struct containing the feature's associated properties. The geometries stored in GeoJSON are loaded as geometry types, so we can operate on the data frame without explicitly creating geometries, like we did loading the CSV file. So here we're filtering for all watersheds that intersect with California and visualizing those using Sedona Kepler. And here we can see our watershed data. Now, if we have large files or many files to upload to Wherobots Cloud, instead of uploading files through the File Manager UI, we can also use the AWS CLI directly by generating temporary ingest credentials. So we can do that here on the Get ingest credentials button, and we'll generate temporary credentials that we can use with the AWS CLI. These are good for 1 hour. So to use these, the first thing we'll need to do is add these access keys to our AWS command line configuration. We'll edit the credentials file. Here, I just have a single AWS profile. We could have multiple named profiles as well. We'll paste in our access key ID, our secret key, and the session token. Give that a save. And now we can choose the directory that we want to upload our data to. So I want to choose the getting started directory here. So I'll copy the S3 URL for that path. In the sample data directory, I have a roads shapefile. Now we all know that shapefiles are composed of many different files. So I want to upload the roads shapefile directory. So we'll say AWS S3 copy recursive, since this is a directory, our roads shapefile, and we'll upload that to our Wherobots S3 directory. This will use our AWS ingest credentials. And don't worry that we showed our credentials on the video. Those will be expired by the time this video is uploaded. Like we said, those credentials are valid for 1 hour. This is really handy if we have many hundreds, thousands of files or very, very large files that are inefficient for uploading through the web UI. And now that that data has finished uploading through the AWS CLI, we can see the shape files are loaded in our getting started directory. So we'll go ahead and copy the S3 path to that directory. And in our notebook environment, we'll reference that getting started directory. Now to import shapefiles, Sedona has a shapefile reader, which will first generate a spatial RDD from the shapefile, which we can then convert to a spatial data frame. This is a data set of Forest Service roads. So let's go ahead and visualize those in Sedona Kepler, just to make sure our data uploaded as we expected. And here we can see our Forest Service roads from the shapefile that we just uploaded. Now, so far we've been working with vector data, geometries and their associated properties. We can also work with raster data in Wherobots Cloud. Here we'll load a GeoTIFF as an OutDB raster using the rs from path spatial SQL function. Once we've uploaded the raster image, we can use spatial SQL to manipulate and work with the band data. First, let's visualize the image. We can see this is an orthographic image of this looks like a forest and road scene. So this image is going to contain 3 bands, red, green, blue. We can use the rs map algebra function to calculate NDGI, which is a metric similar to NDVI used for quantifying health and density of vegetation and land cover. The rs map algebra function allows us to execute complex computations across bands or also across multiple rasters if we for example, had a sequence of images across time and you're interested in change detection. A common workflow with Wherobots Cloud is to load several files, perform some geospatial analysis, and save the result as part of a larger data pipeline, often using GeoParquet. GeoParquet is a cloud-native file format that enables efficient data storage and retrieval of geospatial data. So let's perform some geospatial analysis using the data that we've uploaded here, and we'll save the results as GeoParquet. So we'll perform a spatial join on our bird observation data, joining the boundaries of our watersheds, and then with a group by, getting a count of the number of bird observations in each watershed. So the GeoParquet file that we'll save will include the geometry of each watershed boundary, the count of bird observations, and the name and ID of each watershed. Let's just visualize that again using Sedona Kepler, just to clarify what we'll be saving. Here's our watersheds, and we can see we have the number of bird observations for each watershed as well. So we can choose to visualize fill color based on that field. And let's change the color palette a little bit. There we go. So we can see we have more observations occurring in these watersheds along the coast. We'll save this GeoParquet file to our Wherobots private S3 bucket. Now, previously we accessed the S3 URL via the Wherobots File Manager UI, but we can also access it as an environment variable in the notebook environment, this user S3 path. Since this file isn't very large, we'll save it as a single partition, so a single GeoParquet file. Typically, we would want to save partitioned GeoParquet files partitioned by a geospatial index or administrative boundary. The Sedona GeoParquet writer will add the geospatial metadata when saving this as GeoParquet. Well, that was a quick look at working with files in Wherobots Cloud. You can get started with large-scale geospatial analytics by creating a free account at wherobots.services. Let us know in the comments what you think and what you'd like to see next. Cheers!